Let's do the practice problems for lesson 25. So question 1. Jada has p pennies and n nickels that add up to more than 40 cents. She has fewer than 20 coins altogether. So we've done a few of these in the last few lessons. The first thing we're going to do in part A is write a system of inequalities. So the variables we're going to be using are p for pennies, n for nickels. And so they have to add up to be more than 40. So that's going to be p plus n has to be more than 40 cents. And then she has fewer than 20. So that has to, this is the total amount of money. It has to be more than 40 cents. So we know that pennies are equal to 1 cent and nickels are equal to 5 cents. I could also do this all in decimals, but I'm going to just do it in cents. So I think that's going to be a little bit easier. So it's going to be 1p plus 5n has to be more than 40. And then she has fewer than 20 coins altogether. So that's going to be p plus n has to be less than 20. Part B. Is it possible that Jada has each of the following combinations of coins? If so, explain or show how you know. If not, state which constraints the amount of money or number of coins it does not meet. Now, if we have the graph here, we could just look at the graph and see which one's shaded, but because we don't, we're going to have to do a little bit of substitution. So that first one, 15 pennies and 5 nickels, I can see straight away that it's not going to satisfy that second one, okay? And the reason it's going to be a no, I'm going to say is because 15 plus 5 is not greater than 20. So it doesn't satisfy the second constraint. The next one, 16 pennies and 2 nickels, that does satisfy the second constraint. I would need to check the first one. So the first one is 16 plus 5 times, in this case it'd be 2, because there's 2 nickels, and I want that to be 40, or greater than 40, which it's not going to be. So I would also say no for the second one. I'd probably leave my calculations there as part of my reasoning. I'm going to say because this combo is less than 40, and we want it to be more than 40. And then last, 10 pennies and 8 nickels. It works for the second one. For the first one, we could go ahead and work it out. 10 plus 5 times 8. Is that going to be greater than 40? Sure is. 10 plus 40 is 50. 50 is greater than 40, so that would be a yes. And I would say it does, if so, explain or show how you know. So I showed the first constraint worked. I'd probably show the second one, just to be on the safe side. 10 plus 8 is less than 20. And that would be enough for showing that it works. I'll add a statement here. Works for both constraints. All right, so that is the first one. Question number 2, a triathlon. A triathlon athlete swims at an average rate of 2.4 miles per hour and bikes at an average rate of 16.1 miles per hour. At the end of one training session, she has swum and biked more than 20 miles in total. The inequality is given, and this graph represents the relationship between the hours swimming, S, and the hours biking, H, and the total distance that the athlete could have traveled in miles. My said, I'm not sure that the graph is right. For example, the point 10.3 is in the shaded region, so 10.3 is what, right up here. But it's not realistic for an athlete to swim 10 hours and bike for 3 hours in a training session. I think triathlon athletes generally train for no more than 2 hours a day. So she's adding a second constraint onto this. So if they train for no more than 2 hours a day, then S plus H is going to have to be less than 2. And we're supposed to, on part B, graph the solution set to your inequality. So on that same graph, I would probably just do the intercepts, which pretty easy here. If S is 0, H is 2, and if S is 2, H is 0. So on my graph, that would look like here, here, and I'm going to connect those points. And it's everything less than that. So that's just going to be this little tiny shaded region right here where they overlap. Okay, all of this is part of it as well. Okay. And it says determine the possible combination of swimming and biking times that meet both the distance and the time constraints in this situation. So it's going to have to be something in that little shaded region right there. So maybe, oh, I don't know, I could probably go 0.5 hours. I'm going right in the half there, 0.5 hours of swimming. And, oh, you know what? I'm going back and reading the things. When it says no more than 2 hours a day, that's going to be less than or equal to 2. Okay, and I did put the solid line up there because you can actually go right up to 2. So if that's the case, then I'm going to go up to 1.5 hours. Sorry, I missed that the first time I read it. 1.5 hours of biking. And this is only one possible answer. You can go ahead and get other combinations as long as they're in that shaded region and make both of the inequalities true. Question 3. Ellen is considered buying a bracelet and necklace as gifts for her friends. Bracelets cost $3 and necklaces cost $5. Let's highlight that. And she can spend no more than $30 on gifts. Ellen needs at least 7 gift items. So the graph represents, there's the inequality that represents that information. Let B represent the number of bracelets and N the number of necklaces. Write an inequality that represents the number of gift items that Elena needs. So on this one, you're told that Elena needs at least 7 gift items. So that would be B plus N has to be at least 7, so that means greater than or equal to 7. On the same coordinate plane, graph the solution set. Same thing, like I'm just going to do the intercepts, which are going to be at 0, 7, and 7, 0. So that's going to be right here and right here. Connect those. This is a greater than or equal to, so it's going to be a solid line. And I'm going to shade everything above it. So the solution set for this system is everything that's been shaded twice. So that's this little part right in there, the yellow part that I just colored in. C, use the graph to find at least 2 possible combinations of the bracelets that Elena could buy. I would probably I'll go right here at 7, 1. So 7, what is that, bracelets? And 1 necklace. That would be one possible answer. And then I'll pick another one right here, 6 and 2. So 6 bracelets and 2 necklaces. And you want to make sure that you do pick whole numbers in this one because you aren't going to buy like 0.5 of a necklace or a bracelet. So you do have to look where the grid lines come together. There's some more combinations I could have gotten, but that's 2 possible ones. Explain how the graph shows the combination of 2 bracelets and 5, show that the combination 2 bracelets and 5 necklaces meet one constraint in the situation, but not the other. Now, it's really important that you read the directions here. It says, explain how the graphs. Sometimes people will automatically go and want to like substitute it into the inequalities and show that it doesn't work for one, which is fine, except that's not what the question's asking you to do. So 2, 5 is going to be right there, right? Yeah, 2, 5 is going to be right there. And so you can see that looks like it's right, that is right on the line of the B plus N is greater than or equal to 7. So I will say it satisfies B plus N is greater than or equal to 7 because it is on that line. And it's okay to be right on the line because it's a solid line. So that means those are included. But it is not in the shaded region for our other inequality. So if it's not in that shaded region, it's not going to work. So that other inequality is the 3b plus 5n is less than or equal to 30. And again, I could plug in 2 and 5 into this, okay, but that's not what the question's wanting you to do. It's wanting you to use just the graph. Question 4. A gardener is buying some topsoil and compost to fill his garden. His budget is $70 topsoil and $1.89 per cubic foot, and compost costs $4.59 per cubic foot. Select all of the representations that correctly describe the gardener's constraints in this situation. Let T represent the cubic feet of topsoil and C represent the cubic feet of compost. So there are my variables. The budget is $70, cost for topsoil, cost for compost. So A, the combination 7.5 cubic feet of topsoil and 12 cubic feet of compost is within the gardener's budget. So we could substitute, or we could just look. 7.5, 12, that is gonna be, 7.5 is right in the middle here. 12, these are going up by 10, so this is 12.5, so it's gonna be a little below, it looks like that's really close. Like I might actually wanna check that point to see if it works. So if I take this one, and let's just go through, it hasn't given us an inequality, so I'm just gonna work it out. If I take, let's see here, 7.5, I'm just doing my calculations on the other side. In fact, it is going to work. So A is going to be a solution. If the line represents the equation 1.89t plus 4.59c equals 70, this graph represents the solutions to the gardener's budget constraints. That is not going to be correct, okay? There's nothing wrong with the equation. That is going to give us that line there. It says this graph represents the solutions to the gardener's budget. If you just graphed this line, that's all it would be. It would just be a line. It wouldn't have the shading part, and it would have been a solid line, which doesn't exactly show what's going on in this problem. Part C, 1.89t plus 4.9c is greater than or equal to 70. That is incorrect because it should be less than or equal to 70. The budget is $70. That's the maximum that you can spend. D, the combination of 5 cubic feet of topsoil and 20 cubic feet of compost is within the gardener's budget. You could just look at the graph real quick. That's way up here. That's not in the shaded region, so that's not going to work. E is going to work. Okay, it's the same as what we had in C, but the inequality is going in the correct direction. And then the last one, F. If the line represents the equation 1.89t plus 4.59c equals 70, this graph represents the solutions to the gardener budget constraint. And that is true because the line, okay, the line is the constraint. That's like the thing that's bounding the region. Now, you would have to go through and do the shading and turn it to a dashed line to represent the solutions. This is kind of a subtle difference. The reason that B was wrong is because it said the graph represents the solutions. Okay, the line doesn't represent the solutions. What the line represents is the constraint. So just a minor little difference there, but it's an important one to know why one is true and one is not. And then question 5, we're getting into our review part. Priya writes the equation, write an equation that has exactly one solution in common with Priya's equation. So here, these are gonna have they're gonna have really an infinite number of answers. So I'll just go ahead and show you one. Let's go, I don't know. What's one solution up here? Well, we know that the y-intercept for this one is going to be 0, -7, because this is in the form y equals mx plus b. And so we can see that the y-intercept is 7. So really, any equation that has an intercept of -7 is going to have a common solution. So let's go y equals 2x plus -7. That would also be in common. Something that has no solutions in common, Well, then I'd be looking for a parallel line, okay, that doesn't intersect this. So I'd want to keep the slope the same. So y equals negative 1/2 x, and then it could be any other y-intercept. Or, yeah, I'll just do plus 1. Infinitely many solutions in common with Priya's equation, but looks different than hers. So that means I need to take Priya's equation, and I need to kind of manipulate it a little bit, play it around, but keep it equivalent. So we know to create an equivalent expression, one way to do that is by multiplying both sides by the same amount. So let me multiply both sides by 2. 2y equals, that would be negative x minus 14. And you can also create an equivalent expression. I could just leave it at that, but I'm going to go ahead and add the same thing to both sides. Add x to both sides and go over here with that. That would give me x plus 2y is equal to minus 14. So that equation right there is the same as Priya's equation, but it is looks in a different format. But they're equivalent to each other, so they'd have the same solutions. And if you graph those two lines, it would be the same line. Question number 6. Two inequalities are graphed on the same coordinate plane. Which region represents the solutions to the systems of the two inequalities? That is where they overlap, and so that is going to be region C. Okay, down here is where they both overlap. And question 7. I think that's the last one. Here is a riddle. The sum of two numbers is less than 10. If we subtract the second number from the first, the difference is greater than 3. Excuse me, write a system of inequalities that represents the situation. Let f represent the first number and s represent the second number. Okay, so on this one, we're just writing the system. We don't actually have to solve it. So the first equation, the sum of the two numbers, so f plus s, those are the two variables that I'm using, is less than 10. So less than 10, there's my first equation. And my second equation, if we subtract the second number from the first, so the second number from the first, the difference is greater than 3, greater than 3. So that is my system of equations. That's the first one, there's the second one.